so today we're going to talk about corresponding parts of congruent triangles. Okay, so if two triangles are congruent, then all corresponding parts are congruent. So if we know that triangle CAT is congruent to triangle PIG, then we can conclude that angle C is congruent to angle P because they are corresponding parts. We know that angle A is congruent to angle I, and angle T is congruent to angle G. We also know that segment CA is congruent to segment PI. Let's go ahead and mark those. So angle C is congruent to angle P. Angle A is congruent to angle I, and angle T is congruent to angle G. Segment CA is congruent to segment PI. All right, then we also know that segment AT is congruent to segment IG, so we can mark those. And then finally we know that segment CT is congruent to segment GP. Oh no, sorry, PG. We want to put it in the same order. All right, so that's how you would list all of your corresponding parts. So let's take a look at proof number 16 that involves corresponding parts of congruent triangles are congruent. Now here's an example of a flowchart proof. It's very similar to a two-column. It's just formatted a little bit differently, and some people prefer flowcharts over the two-column. So we start with our givens. Angle 1 is congruent to angle 4, so we're going to mark that on our diagram. And then underneath our statement, we write the reason. So the statement goes in the box and the reason goes under the box. Then we also know that angles 3 and 2 are congruent, and again, that was given. Okay, so we've got those markings. Now, they've given us a reason, reflexive property of congruence. So we need to figure out what statement will go with that. Well, what would be using the reflexive property? Segment AC is congruent to segment AC because both of these triangles use segment AC. They both have segment AC as a side. So now we're going to use angle, side, angle. Angle, side, angle is going to be our reason for why our triangles are congruent. And then we have triangle ABC is congruent to, okay, so we've got A, B, C. So we've got the 2 mark, so we've got to start with C. And then we go over to the one that has nothing, so on this triangle it's going to be D. And then we go down to the angle that has 1 mark, and in this triangle that would be A. So CDA is the proper way of naming the congruent triangle. Now, because these two triangles are congruent, and D and B are corresponding angles, we can say that they are congruent. So, corresponding parts of congruent triangles are congruent. And yes, I want you to be writing that all out for now. Notice, I did not write out angle, side, angle because we've had enough practice with that you should be able to remember that that's what that stands for. So until we get used to what these words mean, corresponding parts of congruent triangles are congruent, we're not going to use an abbreviation just yet. Okay? So now you're going to go ahead and you're going to try proof number 17 on your own. Okay? Then after you've done that, or before, either one, you're going to come over here to the definition of an isosceles triangle. And again, I'm sorry that it's really hard to see, but that's why we're going to go over it together. All right, so this is definition of an isosceles triangle. Okay? A triangle with at least 2 congruent sides. Okay, so we're over here on proof number 23, and now you can see that there's a blank there, okay? So you can use whatever kind of proof you want. You can do a paragraph proof, which is just really writing it out in words. You can do a 2-column proof like we've done in the past, or you can do a flowchart proof like the problem that we just did, okay? So I'm going to go ahead and do a flowchart proof. All right, so our first statement is that Mn is congruent to Me. And we know that because it's given. Okay? So then I'm going to mark that on my diagram. Okay? Then we know that segment MT, I should probably make that a little bit longer, otherwise I'm not going to be able to fit it, bisects angle NME. And again, that is given. Okay? Now, what does it mean to bisect? It means it's going to cut this angle in half. So NME. This angle right here is being cut in half. So that's going to make angle 1 and angle 2 congruent. So from that, which is why there's an arrow there, we know that angle 1 is congruent to angle 2. And that's the definition of a bisector. Okay, so now we've got side and angle, and we want to try to show that these two triangles are congruent, and they share the side MT. So now we can say segment MT is congruent to segment MT, and that's the reflexive property. That's our reason. All right, so all three of these statements lead us into the statement that triangle NMT is congruent to triangle EMT. And the reason we know that is side angle side. Okay, so now we have two congruent triangles, and we can use the corresponding parts to show that angle N is congruent to angle E, because these two are corresponding parts. Okay? So we have angle N is congruent to angle E. And again, that's corresponding parts of congruent triangles are congruent. Right, so that's an example of a flowchart proof using an isosceles triangle. All right, now let's take a look at the isosceles triangle theorem, or base angle theorem. Okay, because we've just shown now here that these two angles are congruent. So these are called the base angles. Wherever the congruent sides come down to the base is one of the sides that is not congruent. That's called the base, and the angles are the two angles that are attached to that. So what do we know about those two angles? Well, we've just proven that the base angles are going to be congruent. So if a triangle is isosceles, then the angles that are opposite the congruent side, so this angle is opposite this congruent side, and this angle is opposite this congruent side, then they are congruent. Those angles, those base angles, are going to be congruent. Okay, so what does that mean for our hypothesis and conclusion? If we have segment AB is congruent to segment AC, then angle B is congruent to angle C. Okay? So that's the conclusion we can make if we know we have an isosceles triangle. So now I want you to go ahead and try proof number 24. You can use any kind of proof you want. You can do flowchart, 2-column, or if you like to write things out in words, you can use a paragraph proof. So you're going to try number 24. So when you come in tomorrow, you should have number 24 done. And then again, you should also have number 17 done.